In this lesson, we're going to take a look at the derivatives of the trig functions, sine and cosine, and then we'll look at tangent, and then the rest of them. So if f of x equals sine x, we're going to use the squeeze theorem, which we use to show sine h over h is 1 and cosine h minus 1 over h is 0, and some trig identities, sine of a plus b, cosine a. Okay, so we have those. We're going to use those in order to find the derivative of the sine function. So we know the limit definition of the derivative says this is equal to the limit as h goes to 0 of sine x plus h minus sine x all over h. Okay? We're going to go ahead and use the sine of a plus b is equal to cosine a sine b plus sine a cosine b to rewrite this. So this is equal to the limit h goes to 0. We have cosine x times sine h plus cosine h times sine x minus sine x, right, all over h. Then all we're going to do is rewrite this in a convenient method so that we can actually use these facts to simplify this a little bit. And so what I see here is I have a cosine x sine h, cosine h sine x sine x. So there's sine x in both of these terms, and I have this sum. So I'm going to go ahead and split this apart. So this is equal to the limit, h goes to 0, of cosine x times sine h over h, plus the limit, h goes to 0, of sine x times, I'm going to factor that out, cosine h minus 1 all over h. Well, these terms, without the h's in them, I can bring those out in front of the limit. So this is equal to cosine x times the limit, h goes to 0, of sine h over h, plus sine x, limit h goes to 0, of cosine h minus 1 over h. Well, cosine h minus 1 over h, limit h goes to is 0, so this is 0, and sine x times 0 is 0, and sine h over h, limit h goes to 0, that's 1, so this is just cosine x. And so we see that the derivative of sine is cosine. We can use a similar process to find the derivative of cosine. So if we have f of x is equal to cosine x, then switch to a less squeaky marker, then f prime of x is equal to the limit as h goes to 0 of cosine x plus h minus cosine x all over h. And then we're going to use this rule to rewrite cosine x plus h. So this is limit h goes to 0 of cosine x times cosine h minus sine x times sine h, and then I still have this minus cosine x, and this is all still over h. And then again, we will rewrite this a little bit, and so this is equal to the limit h goes to 0, and I'm going to split this difference and I'm going to factor out that cosine x. So this cosine x right here, I'm going to shift it over here so I have cosine x times cosine h minus 1. This is all over h. Minus the limit h goes to 0 of sine x times sine h over h. And again, I can pull that cosine x out front, and we know that this term is 0, and so this is 0 minus, and then I have sine x times 1, so 0 minus sine x, which is just negative sine x. And so we see the derivative of cosine is negative sine. Now we want to look at the derivative of tangent, and we're going to recall what we just proved, that if f of x equals sine x, then the derivative of that is cosine, and if f of x equals cosine x, then the derivative is negative sine. So with those two facts in mind, we're going to go ahead and look at tangent. f of x equal to tangent x. Okay? And for this, we remember that this is sine x over cosine x. Well, now we can just use the quotient rule. The derivative of the top, derivative of sine is cosine, times the bottom, times cosine, minus the top, times the derivative of the bottom, negative sine, all over the bottom squared. And now we just have to use a little bit of our trig identities. Cosine times cosine is cosine squared. Negative sine times negative sine is plus sine squared, all over cosine squared. Well, sine squared plus cosine squared is equal to 1. It's the Pythagorean identity. Over cosine square x, this is just secant square x. So the derivative of tangent is secant squared. And now, if we know sine, cosine, and tangent, if f of x equals tangent x, then f prime of x is secant squared. We can use those to find the identities or the derivatives of the other three trig functions, secant, cosecant, and cotangent. Leave that as an exercise for you, but now that we have the derivatives of sine and cosine, really, we can use identities and we can use quotient product rule to figure out what the rest of these derivatives